wavelength is nothing but electromagnetic energy, electrical energy, right, that continues through the feeder line, okay, the coax or anything else, so many things that we can use, that feeds the antenna. The antenna radiates. It pushes this into electromagnetic waves through, that is a wireless signal, right? Radio waves, whatever you call it. Now, every frequency that we use will have a wavelength. And this wavelength is nothing but the length that is, or the measure of its transport from one point to another with respect to speed of light. The speed of light is whatever it is, 300,000, etc., etc., etc. But that is, in vacuum, it is different. The velocity, light, in vacuum it is different. In space, outer space it is different. Which means, in vacuum if you put air, then the velocity will vary. It becomes faster. And then which means, instead of air, if you keep adding any other thing, okay, maybe gas, or maybe water, maybe something, then the velocity will also should change, logically. Now this is exactly what happens when electromagnetic radiation is comparatively much faster than light. Because this transmission happens not just in empty space or in vacuum, but it has to go through a channel, or go through a pipe, or go through a coax, or go through a feeder system. And in that feeder system, what happens, since it is not vacuum, it has many other atoms and other things put in, the velocity is much higher. So if you calculate for 145 megahertz, right, the formula gives you with the velocity, no velocity, nothing, it says something 36 inches or 38 inches. But when you put it through some material, any material which is a conductor, the feeder, depending upon the type of conductor, depending upon the conductor characteristics, the velocity will vary. So much so what happens, if you take a coax, this coax has capacitance, it has resistance, it has dimensions, it has dielectric and so on and so forth. Because of this, the velocity is not equivalent to light, and the velocity is much, much faster. So there is one thing known as a velocity factor which you should do the calculation. For example, this is RG58U cable. The velocity factor is 66% or 68%, depending upon the insulation side. If you take RG8U, it is about 95 or 97%. If you take like that, the higher cost and the more professional cables, right, have very closer to 100. But the cheaper cables, so the idea here is to make use of that, because that is what decides the SWR. That is the one that decides how much is the cable loss, phase charge and all that stuff. When we calculate, if we include the velocity factor, you will see that automatically the length becomes more. So the simple secret here is, you calculate for halfway, and then depending upon what material, you have to give a correction factor. For example, if you use a thin wire, thin cable, there is a correction factor for it. If you use a thicker cable, there is a correction factor for it. This correction factor depends upon the diameter of the conductor or the element, and the length starts becoming lesser and lesser and lesser. So this is one point. The second point is, when you take this and it has a velocity factor, all you have to do is calculate this to get 39 inches, okay? Cut off 66% to 66%, and you will get only 2 feet more. So from 3 feet, it will automatically become 2 feet. So this cable has a velocity factor, like I said, 0.66 or 66%. It's very simple. So I make this because, okay, these are all old cables which I had from the past 30, 35 years or so. Most of them are stiff, I don't know how they are, what they are. But when I cut this, I found this is an excellent cable. Very well cut off. So this is one simple thing that I wanted to share with everyone. Right? But this is my favorite. I've been doing this from long time, more than 3 decades.
Out of curiosity, that's the best velocity factor that you can come to, 0.66.
Yeah.
Make it even shorter.
Yeah. Because this is the cheapest cable.
RGP.
And this is the one with the higher loss.
The more inferior the
Is
cable is,
even higher
better
loss?
the UGA,
And
thinner the cable,
that is-
thinner the conductor.
Who said that?
Thinner the cable, the higher the loss.
So what if it's a solid one?
Lower the
No, not
velocity.
necessarily thinner the cable.
Because the energy tends to
It is
flow on the
it is
surface of the
thinner
conductor.
cable plus the diameter. The diameter
Quality
is
is
very
one.
important.
Also the cross section of the conductor
Yeah.
determines the velocity factor.
Yeah.
Second is also because the electromagnetic energy or RF energy tends to higher the frequency, tends to flow more on the surface of the conductor.
It's not just surface. Here it does not go to the
Skin
surface.
effect.
Here what we have done, I tell you.
The skin
This
effect.
is the skin effect. Yes, also being used. I will come to that later. But since you have put down, if you look at this, okay, you can come closer and have a look.
Dipole.
This is basically a dipole. It's a dipole cut for 140 on 144 megahertz
With a correction factor of 0.6.
with correction factor of 0.66. So it gives me about 2.2 feet.
Instead of 19 inches, it becomes smaller.
No. Instead of 19 into 2,
That's it. 19 into
38 or 39. This is
Around 11.
How much is this?
12 feet 1 inch.
2 inches.
What is the dimension?
26.
Half of it.
24, 26,
Yes.
24.5,
The first thing is
25,
26.
approximately 25 inches. Yes.
SWR, if you measure it, give 1:1, is it?
The SWR will again depend upon the same characteristics of how you build the Yagi, how
No,
you
no.
fit it and all that.
If you tune this at the frequency,
Ah,
it will give 1:1.
of course it should. But the Yagi doesn't give one.
See, there are 2 points there for SWR. One is at the feed point, one is at the radio end.
So it depends. The SWR is never 1:1. If you get 1:1, there is something else wrong.
What is the best SWR?
Yagi, believe me. I'm sorry. Yagi, believe me. It's not easy to get 1:1. Impossible. I mean, I will say
I mean,
impossible.
I'm talking, let's say,
Yeah, I know.
conventional to
What
this.
is to 2 or 3, whatever?
No, because a lot of people are here.
To a conventional Yagi to this Yagi I'm talking about.
This is a short version. Short, small version. The elements
No,
are
what is there something that we lose by, or is it as good as the regular
it's
Yagi?
as good as any egg. The only thing is physically it is small. Now when I
The
make a full-
advantage is the size.
the size. See, this one will go into my car as is. But if I make a full-blown Yagi with metal, right? We had our things all cut and all those things from my experience. Right? So I was looking for shorter and shorter. So first I made only 2 elements, other 2 telescopic, right? I have foldable, and then umbrella type like this, floating like this, all of them, all these things. But then ultimately I came out to this, right? You simply dump it there in then sit down in between, go.
Basically meant for portable operation for box science. Ultimately, that is
What
the
I
That is also
also
about
wants
my-
to know, I understand is, will this be an advantage over that, or will that be an advantage over this, or will it be equal?
There is no
You can
advantage.
tune it as equal to that.
Yes. It behaves the same as any egg.
Any.
Main advantage we already mentioned that.
And not only that. Okay, now you want another thing. If you are putting a half wave antenna, vertical or a quarter wave, if you use a coax, that will also push out. The vertical antenna?
When
No,
you
but-
use it vertical, do you short on the top and bottom?
No, the bottom is over the top.
Both.
Yes.
Top is
Because
short. That's what I'm asking. Top is short, bottom is open.
the feed point
Yeah, is open.
is open.
Open.
What happens here is, like Nat said, the radiation electromagnetic waves travel on the skin. It's a skin effect. So what we are doing here is, we are transforming that energy, we are feeding it to the center of the coax. So the coax runs up to here, then we short it, so then it continues, the conduction continues on the outer. So this is the secret behind the shortening and how it works. We also call, there are a lot of other things called bazooka, etc., etc.
I think
Some
these
of
are
them are very
the
complex.
that this one, no? Umbrella type.
ಇಲ್ಲ ಅದು ಸುಮ್ಮನೆ ಓಪನ್ ಬಿಟ್ಟಿರೋದು
Okay.
Flop
That's right.
simply left like that.
So, this is, and it fits pretty well. You can use a balloon if you want or not, also it is fine. Right? You can just feed it over here.
So here
The
again,
ends
this
here are
element are
if you
shorted.
see, the ends are shorted here to the center conductor to the brain, right? But these are all but these elements, reactors and all that are open.
And why have you kept that rotating?
Which one?
Something specific? Why is this moving?
Kelagade.
That is what very
These are
important.
the profile like moving on.
We can use this
Oh,
for engine
that's
also.
okay. I was
This should
wondering
not
if
break.
there is something behind that.
This is foldable because, okay, parallel hard portable.
Correct, I understand.
I have no
Center
kind
stuff,
of
ಈ ಸೆಂಟ್ರಲ್ ಇರೋ ಜಾಕೆಟ್ ಸುಮ್ಮನೆ ಇದೆ.
ಯಾವುದು ಇದಕ್ಕೊಂದು ರಬ್ಬರ್ ಬ್ಯಾಂಡ್ ಹಾಕಿದ್ರೆ
ಇದಕ್ಕೆ ಹಾಕಿದ್ದೆ.
Just to hold it.
ಇದಕ್ಕೊಂದು ಟೇಪ್ ಹಾಕೋದು ಅಷ್ಟೇ. Because see this one I didn't have the.
I'm wondering whether you have got some gamma match through that.
ಇದು ರಾತ್ರಿ ಮಾಡಿದ್ದು.
Gamma match ಗೆ ಇಟ್ಟಿದ್ದೀರಾ?
I heard you about Gamma Man. That's what I wanted to know. Why is this moving? Is there something? It is only to carry. It is to carry and without damage.
Actually, okay, once you get ಹೇಳ್ಬೇಕಂದ್ರೆ you can use it to attenuate the signal.
Oh, attenuate of signal. If you have
You
some
can
option,
alternate, yes.
this is what is
One is
the option.
alternate, but will there be any change in direction at all? Suppose you turn it.
No, see,
Directors are here.
Directors are here.
ಡೈರೆಕ್ಷನ್ ಅಲ್ಲ ಗೇನ್ ಹೋಗುತ್ತೆ
Gain ಕಮ್ಮಿ ಆಗ್ಬಿಡುತ್ತೆ.
ಗೇನ್ ಹೋಗುತ್ತೆ ಡೈರೆಕ್ಟಿವಿಟಿ will remain the same.
That is as good as attenuation then. It is attenuation.
Bypassing attenuation.
Sort of attenuation itself.
So now we know why he wins the fox hunt.
Ha ha. Secret out. It-
No, please stand up and ask the question. He will not.
We are not able to. Who is asking the question? Will not be able to know.
ಬಟ್ ನನ್ನ ಪ್ಲಾನ್ ಇಷ್ಟು ತಪ್ಪ ಇದೆ ಅದಕ್ಕೆ ಹಾಕಿಲ್ಲ.
And
You get a straight radiating pattern. That means you are directional. If this is skewed, you have at least a bandwidth, beamwidth to play around with.
The thing is, you also have the FNB, forward back.
No, this is basically as a.
You will know that it is signal here.
Now,
And
this is basically intended as a receiving antenna or transmitting
no, no, it's a
antenna.
transmitter antenna.
Fox hunt.
It's there, what is that? I know feedback cover fits it in.
Duck.
This also I'll put
What's this as a question?
Making the
What about the spacings? Do that the
problem is you not see for this unless you have
reflector, director and the thing, any
Use the standard Yagi.
Standard.
Number one. Number two, this one, SWR time idaga, I kept on moving this also and trying to find out where the forward and back ratio is.
you mean
better.
this one, the coil?
No, distance between the.
Oh, this one you hold up and down.
So this one I have optimized basically for the FP. Forward reverse. Right? It can be done.
Pujit.
Another question that came from
Yeah, please.
Can the same concept be used for HF to reduce
Of course it can be.
Or-
Of course, why not? You can use it for anything. Because velocity factor is there for all the parts.
So the our elements should be okay, but elements should become shorter.
Elements will be flexible, whatever.
No, I meant instead of our regular.
See, when you use a cable, okay, I'll tell you that again.
Short here.
Yeah, the end is
And feed the center.
center is open.
center is open,
Okay.
feed point is open, ends are shorted.
There is no border.
How is
Yeah,
it
here
done?
we feed in the center point.
How is that?
See, it's basically.
Hot and cold.
Okay, that is all. Nothing else. Where is it? But hill center ಅಲ್ಲೇ ಇದೆಲ್ಲ.
Center ಇದೆ, feed point.
Okay.
There you have to coax. The blade is short. Like that.
Okay. And,